Good morning everyone. I am Pavitra, Department of Mathematics, working in Erode Engineering College. Today we are discuss about that vector calculus and complex variable. What is mean by vector? Vector is an direction. The notation is an arrow mark, and calculus mean that rate of change of momentum, and complex we already known that lower level class real part and imaginary part values are occurs. Then variable means that x, y, z. Under this topic we are going to discuss about the first unit is an vector differentiation. In this unit you can only occurs for an partial differential equation. It is denoted by dou u by dou x. The application of the vector differentiation is navigation by air, and second one both water generator as a force in one direction. So under this topic we are discuss about that one by one. The first topic is vector point function or vector differential operator. Second one gradient. Third one is directional derivative. Fourth one is unit normal vector. Fifth one is normal derivative. Sixth one angle between two surface. Seventh one orthogonal of the scalar point function. Eighth one scalar potential. Ninth one divergence and curl. Tenth one solenoidal and irrotational. The first 5 topics are only 2 more questions. The next 5 topics are 8 more questions. So discuss one by one. First topic is an vector point function or vector differential operator. The vector differential operator del is defined as del is equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z, where I vector comma j vector comma k vector are unit vector along the three rectangular axes Ox, Oy, Oz. Here ijk vectors are unit vector means that I vector dot I vector is equal to 1 and j vector dot j vector is equal to 1 and k vector dot k vector is equal to 1. The next topic is gradient or scalar point function. Let pi of x, y, z be a scalar point function and continuously differentiable, then the vectors del pi is equal to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z is called the gradient of the scalar point function pi and is written as del pi is equal to del pi. So in this definition says that del is an differential operator, pi is an given function. The function is occurs the variable is x, y, z. Thus variable is continuously differentiable. You can substitute pi value is any function. First one I vector dou by dou x. So here the function pi is another function of x. You can differentiating with respect to x. Plus j vector into dou pi by dou y. It means that differentiating with respect to y. Plus k vector into dou pi by dou z. You can differentiating with respect to z. Is denoted by gradient of the scalar point function pi is written as gradient of pi is equal to del pi. So the gradients means that del. The function scalar point function is pi. So you can say that del pi is an gradient or scalar point function. Here the note that first note r vector is equal to xi vector plus yj vector plus zk vectors. Second one modulus of r vector is equal to root of x square plus y square plus z square. The third one r square is equal to x square plus y square plus z square. The last one dou r by dou x is equal to x by r and dou r by dou y is equal to y by x. So based upon the problem, first one if pi is equal to x, y, z, then find del pi. Okay, so solution given function is pi is equal to xy. To find del pi, we already known that del pi formula is means that gradient pi formula. So del pi is equal to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. You can substitute pi value is equal to x y z, which is equal to I vector of dou of x y z divided by dou x plus j vector of dou by xy z divided by dou y plus k vector of dou into xy z divided by dou z. In I vector you can differentiating with respect to x. The j vector term is you can differentiating with respect to y plus k vector term is you can differentiating with respect to z. So first term you can differentiating with respect to x means that x is equal to with respect to x means that x value is equal to 1. Remaining as yz. So I vector of yz plus you can second term you can differentiating with respect to y. So y value is 1 can getting the value is xz plus k vector of the third term you can differentiating with respect to z. Z of the term is differentiating value is 1. The balance term is yz. So k vector of xy. Therefore the solution is del pi is equal to I vector of yz plus j vector of xz plus k vector of xy. So the value of the gradient value is the same one. Problem number 2. Prove that del of r power n is equal to n into r power n minus 1 into r vector. Solution. We have to prove that del r power n is equal to n into r power n minus 2 into r vector. We already know that del is equal to I vector of dou by dou x plus j vector of dou by dou y plus k vector of dou by dou z. Since del of r vector is equal to, you have the three terms. So you can simplifying that summation of I vector into dou by dou x into r power n. You can the first term differentiating with respect to x. So r vector having the vectors are x plus y plus z plus the three terms are occurs in the r vector. So you can differentiating with respect to x mean that n into r power n minus 1 because x power n is differentiating term is n into x power n minus 1. The same procedure of differentiation of r vector is r power n vector is n into r power n minus 1 into with respect to r by using as an chain rule. So n into r power n minus 1 into dou r by dou x. Okay, shall we move in next step? Summation of I vector is n into r power n minus 1 into dou r by dou x. We already known that in the first note of first definition is dou r by dou x is equal to x by r. So you can substitute the values x by r. Okay, the next step is denominator in r. So we can move in numerator value r power n 1 minus 1. So the next step summation of I vector into r power n minus 2 into r power minus 1. Here already r power n minus 1 into r power minus 1 you getting the value n into r power n minus 2 into x. So here n into r power n minus 2 is a common term of y, z and x. So we can take outside. So n into r power n minus 2 summation of I vector into x. So that the summation of I vector of x is equal to I vector of x plus j vector of y plus k vector of z. So we already know that the value of r vector is equal to I vector of x plus j vector of y plus k vector of z. So therefore del of r power n is equal to n into r power n minus 2 into r vector. Okay, so any doubt means please comment me the questions. So shall we move in third problem? So the first one, the temperature at a point x comma y comma z in space given by t of x comma y comma z, which is equal to x square plus y square plus z square, full stop. The mosquitoes located at 1 comma 1 comma 2 decide to fly in such a direction that is gets cooled at faster. Find the direction which is to should fly. In this question says that the mosquitoes in placed at one room in the hot temperature room. That the mosquitoes decided at cool temperature. Okay, how to find the direction? The given point is 1 comma 1 comma 2. The temperature is x square plus y square plus z square. Solution: given t of x comma y comma z is equal to x square plus y square plus z square. To find the direction, we already known that del t is equal to I vector of dou t by dou x plus j vector of dou t by dou y plus k vector of dou t by dou z. I vector of I vector value is x square plus y square plus z square divided by dou x plus j vector of dou of x square plus y square plus z square divided by dou y, and k vector of dou of x square plus y square plus z square divided by dou z. So I vector term is you can first differentiating with respect to x. So x square the differentiation value is 2x plus second term differentiating with respect to y. The value is 2y. Then third term also differentiating with respect to z. The numerator in z square. You can differentiating the values 2z. So hence del t is equal to I vector of dou 2x plus j vector of 2y plus k vector of 2z at the point 1 comma 1 comma 2. So next one, del t is equal to I vector of x value is equal to 1, y value is equal to 1, z value is equal to 2. So del t is equal to I vector of 2 into x value is equal to 1, substitute here, plus j vector 2 into y value is 1 plus k vector 2 into z value is 2. So del t is equal to I vector of 2 plus j vector of 2 plus k vector of 4. Therefore the mosquitoes flying at the direction is 2i vector plus 2j vector plus 2k vector. Problem number 4. If pi is equal to log of x square plus y square plus z square, then find del pi. The solution is given pi is equal to log of x square plus y square plus z square. To find del pi, we already know that del pi is equal to I vector of dou pi by dou x plus j vector of dou pi by dou y plus k vector of dou pi by dou z. So I vector dou of pi value. The pi value is an log of x square plus y square plus z square divided by x plus j vector of dou of log of x square plus y square plus z square divided by dou y plus k vector of dou of pi value is equal to log of x square plus y square plus z square divided by dou z. So we already know that differentiating with respect to log x is equal to 1 by x. In the same concept you can substitute here. So you can consider log of x square plus y square plus z square, the two terms taken as x. So same concept, I vector of log of this value differentiating with that 1 by x square plus y square plus z square into with respect to x by using as a chain rule into x square differentiating the term is 2x plus j vector of 1 by x square plus y square plus z square into 2y by and differentiating with respect to y. The same concept, differentiation of log x is equal to 1 by x into the chain rule occurs means that 1. So here differentiation of log of x square plus y square plus z square, the value is equal to 1 by x square plus y square plus z square into 2y. The last term you can differentiating with respect to z. So 1 by x square plus y square plus z square into 2y. Okay, clear? So next step, you can denominator is same. The three steps are denominator is same. So can adding numerator value. So numerator value is equal to I vector of 2x divided by x square plus y square plus z square plus j vector of 2y divided by x square plus y square plus z square plus k vector of 2z divided by x square plus y square plus z square. The denominator is same, so can adding numerator value. So numerator value is I vector of 2x plus j vector of 2y plus k vector of 2z. So divide by x square plus y square plus z square. So in your numerator value 2 is common. So taking outside 2 into xi vector plus yj vector plus zk vector. Divide by x square plus y square plus z square. We already know that r vector value is equal to xi vector plus yj vector plus zk vector. So therefore del pi is equal to 2 into r vector. Denominator value you can already know that r square is equal to x square plus y square plus z square. Okay. Any doubt? Are you clear this formula? Shall we move in fifth problem? So find del pi if pi is equal to x square plus y square plus z square. So solution, given pi value. To find del pi. So del pi formula is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. So you can substitute pi value. So I vector of dou of x square plus y square plus z square divide by dou x plus j vector of dou of x square plus y square plus z square divide by dou y plus k vector of dou of x square plus y square plus z square divide by dou z. The first term you can differentiating with respect to x. The second term you can differentiating with respect to y. The third term differentiating with respect to z. So therefore differentiating with respect to x means that x square differentiate value is 2x. Y square differentiation value is 2y. Then z square differentiation value is 2z. So that I vector of 2x plus j vector of 2y plus k vector of 2z. So next step, the 2 is common, so taking outside. So 2 of xi vector plus yj vector plus zk vector. So we already known that I vector value is which is equal to xi vector plus yj vector plus zk vector. So therefore del pi is equal to 2r vector. So if you have any doubt in 5 problems, you can comment me. Okay. Thank you all.